Look, each student's score is entered out of 100 points possible, and her current scores are out of 5. So what you want to do is calculate a percent, basically, which means you're going to divide by 5 first and then multiply by 100. Now, if you do those things together, it saves you a step. For example, let's go up and do, let's say, let's grab the 4. The 4 is the easiest one to calculate. Most of us would probably be able to look at that and say, oh, well, or maybe some of us anyway. 4 divided by 5 is equal to 0.8. You multiply that by 100, and that gives you an 80, right? Okay. You're doing two things. You're dividing and you're multiplying to get that number. You can do it in one step. 100 divided by 5 is equal to a 20. So essentially, if I multiply the number 4 by 20, I get 80. And so really, if I take all these scores here and multiply them by 20, my new scores, and I'll put them in order. 2.5 times 20 is equal to 50. Okay, 3 times 20 is 60. 4 we just saw is 80. 4.5 is 90, and then the 2 5s times 20 are 100 and 100. So those are the 6 scores. Now, do I have to recalculate all this stuff, especially the standard deviation? That's kind of a pain in the neck. The mean is just that number times 20. Okay, that's an 80. And the median would be that number times 20. That's actually going to be an 85. The mode is also going to be multiplied by 20. That's 100, because now 100 shows up twice. Now the range, let me show you this. This is kind of cool. Because you look at the range, it's 2.5. And if you're not careful, you might say, well, the range is still 2.5 because the standard deviation and the range are unaffected by doing something. Well, multiplying and division affect everything. Okay? So we can calculate the range by subtracting over here. I can also calculate the range by looking at my data points. That's why I had you write a list of them here. 100 minus 50 is equal to 50. So my range did change. Okay? It was affected because we multiplied by 20, all of them. So by that same sense of logic there, this will be 19.2. Now I'm going to stick with the same set of data and say what would her new quiz score be if her parents tried to encourage her to increase each quiz by 1 point. Now, I don't know about other teachers. I'm not as generous as some, but I won't let someone raise a 5 up to a 6, but I see what we're trying to do in this particular case. If the goal is to say that we're adding 1 to each score and we allow for extra credit, then the new scores are going to be 3.5, 5, and then all of a sudden we got a 5.5 and 2 6s. Okay? Again, the point of this is to recognize that adding 1 to all of them is going to affect some of these but not the others. The mean was 4, is now going to go up to 5. The median was 4.25, it's now 5.25. The mode is now a 6. Okay, if that's ever a score that could happen. It's the range and the standard deviation now that I want to point something out. The range from 3.5 up to 6 is still 2.5. That was unaffected by addition of 1 point. The standard deviation, we don't have to recalculate. The standard deviation, unaffected by adding to each. So 0.96 is going to be the standard deviation. The range and standard deviation are unaffected by addition or subtraction.